Hi Pre-Calc. These are the notes for section 6.5, the complex plane. So first of all, the complex plane is just a plane where we can plot complex numbers. Remember, complex numbers are like 5 plus 2i, anything that has like that imaginary I in it. And a plane is just like two axes. So it's a lot like the Cartesian plane that we're used to seeing, like that plain old xy plane. And it behaves the same way. So we're going to see a couple examples of that. So the complex plane is a set of axes for complex numbers. So the complex plane has, we can think of it like an x and y axis, a vertical and a horizontal, and one of them is for imaginary, and that'd be the vertical one, and one of them is for real numbers. That'd be the horizontal one. So like if we were going to plot the point, or plot the complex number, let's say 3 plus 2i, this is the real part and this is the imaginary part. So we're going to go over 3 up 2. Think of it like the point 3, 2. So we're going to go over 3 and up 2. If we were going to plot the point, let's say 5 minus I, that is 5 is the real part, negative 1i is the imaginary part, so that's kind of like the point 5, negative 1. So 1, 2, 3, 4, 5 on the real, negative 1 on the imaginary. Or we could plot things like 6i, which is like 0 in the real spot and 6 in the imaginary. 0, 6. So we're going over 0 but up 6. Or we could even plot real numbers like 4, which is 4 in the real, 0 in the imaginary. So that's like 4, 0. Over 4 up 0. The really biggest difference between the regular Cartesian plane and the complex plane and in terms of like behavior is the idea of the absolute value of a complex number. So to find the absolute value of a complex number, it's kind of like finding the magnitude of a vector, or kind of like finding the distance. So now, we were talking, think of them like points up here. You could also think of this as a vector in standard position that goes out to AB. So the absolute value of a complex number looks kind of like the distance formula, but you could kind of think of it as like magnitude. Remember, magnitude is like the length of a vector. So the absolute value is very similar to that. So let's do a couple examples here. You can add complex numbers with, again, you could think of them like vectors. So you could think of this as like the vector 1, 3, and we're adding the vector 2, that's 1i. And we know that we just add the horizontal components here, so that's 3. And then add the vertical components, that's 4. So you could think of it like a vector this way, but since it's complex numbers, we'll actually write it like a complex number. 3 is real, 4 imaginary. You could do the same thing for subtraction as well. So here's the difference between absolute value and the actual distance between. The absolute value, remember, kind of think of it as a vector that goes from 0, 0 out to these. The distance between, you can actually pretend this is just the point 2, 3. And this is the point 5, negative 2, and use the real plain old distance formula. So that's this one. Oh, sorry, this one should go on the outside like that. So I'm going to do 2 minus 5 squared plus 3 minus negative 2. So that's 3 plus 2 minus negative 2. Square all that. So this is, let's see, negative 3 squared is 9. 5 squared is 25. Taking the square root of 34. You could simplify it further. For now, I'm just going to leave it at that. Last but not least, you can also find the midpoint with complex numbers. Again, we're just going to kind of treat them like points because they're almost the same thing. It's just a different plane, but it behaves almost the same way. So I've got, let's see, 0 in the real here and -5 in the imaginary. So I'm just going to find the midpoint. And the midpoint is this big formula. X plus x over 2 and y plus y over 2. No sense in memorizing a new formula when it's just the same as what we've been doing before. 4 plus 0 is just 4 divided by 2, 2. And 3 plus -5 is -2 divided by 2, -1. So let's write this like a complex number though, because we know they're not actually points, they just behave like points. So that's 2 minus